All right, we are in Algebra 1. Today's date is Friday, March 29th, the day before we go away to spring break. Please put your name and date on your paper. March 29th, 2019. All right, so we are on our third out of our 4 lessons. After we are done with this lesson, you have one more lesson until the test, which means we'll have time to review on Monday, and then your test will be on Tuesday. So I want to talk about the difference between adding and multiplying. It might seem trivial, it might seem kind of dumb that we're doing this because we learned how to multiply and add when we were in maybe 1st or 2nd grade. So repeated addition, adding the same number over and over again. This is the same thing as doing what to the 2? Adding 2 and 2 and 2 and 2 is the same as doing what to the 2? Who wants to hand out the cards also? What? Doing what to the 2? 2 plus 2 plus 2 is 6. So what do I have to do to the 2 in order to get 6? I need a quiet raised hand. Do I add something to 2? Do I multiply something to 2? Do I do 2 to the power of something? What do I do to 2 to get to 6, Jose?
Multiply by 3.
Yes, I multiply by 3. Editor did tell you. All right, so 3 times 2. So adding is the same thing as multiplying that number. Okay, and then when I'm multiplying 2 times 2 times 2, what do I do to the 2 in order to get the answer? 2 times 2, these 2 right here is 4. 4 times 2 is 8, so 2 times 2 times 2 is 8. I said that one too many times, didn't I? 2 times 2 times 2 is 8. So 2, and then what do I do to 2? Do I multiply it again? Do I do something else to it, Cohen? There it is. Yes, thank you, Cohen. 2 to the power of 3. That should be coming back here. And coming back here to Algebra 1, I need to give Cohen just did some XP. My other card that is in here is Andres. No, he's absent. That's why his card is here. Who's the other person that just participated? It was Jose? Okay.
Give Eder some XP. Help me out with this.
Yeah, Eder told you what to write? Okay. And then Jose, for reporting the behavior, you get 10. All right. So I need to fill in these words. The what counts how many times you added the same number. Or do you have a question? Question?
Can I get XP because I saw the...
Sure. You just got to ask for it.
From yesterday too?
If you asked for it yesterday, I would have given it to you. 50. Just got to ask, guys. All right, so the what counts how many times you added the same number. It's that number out front. This number out front has a very special name. I know that this isn't a variable, so it technically isn't this word, but it starts with a C. The number out front of a variable. Does anyone remember that vocab word? The number in front of the variable. Jose remembers. Who else remembers? Josie, go for it. It is indeed the coefficient. Thank you, Josie. And you can turn in your card. So the coefficient will always count the number of times that you've added the same number. For example, if I did x plus x plus x, then this is 3x because there are 3 of these x. And I'm counting things. How many apples do I have? 1, 2, 3. I have 3 apples. X could represent the number of apples. So that coefficient counts the number of times I've added that same number. And x is a number, we just don't know that number yet. Okay, so what counts the number of times you've added? Oh, shoot. Okay, teacher error. Cross out added. This should have been multiplied.
Teacher error.
Yeah, I feel guilty. Everyone that's here, you get 70 XP. All right, the what counts how many times you multiplied the same number. I multiplied, multiplied, multiplied. Go for it, Jessica. It is indeed the exponent. Thank you, Jessica. You can turn in your card. So these are the key differences between adding and multiplying. Coefficient versus exponent. Only the coefficient will change when I'm adding. Only the exponent will change when I'm multiplying. So My example, x squared plus x squared plus x squared. Who can tell me what this is? I see only one hand. That's not good. I need more hands. X squared plus x squared plus x squared is how many x squareds? Fernando, go for it.
3x to the second power.
Yes, 3x to the second power is indeed correct. I have 3 of those x to the second powers. 3 of those x squareds. Thank you, Fernando. And Fernando, your card is now in. I have collected you. Okay, but what happens now? It's the same thing, x squared, and x squared, but this time I'm going to multiply. What am I going to do? How many times have I multiplied the same number? I see 2 hands. What is this going to be? Cohen, go for it.
X to the power of 6.
It is indeed x to the power of 6. I'm just adding the exponents. Add the exponents. Add the numbers out front. If I am adding the exponents, 2 plus 2 plus 2 is 6. If I'm adding the numbers out front, adding the coefficients, 1 plus 1 plus 1 is 3. Adding the coefficients gives you 6. The difference between adding and multiplying is whether or not you add the coefficient or whether or not you add the exponent. That is the key difference. If there's one thing that I want you to walk away, it's with that lesson, the difference between adding coefficient and exponent. If you just have that one rule, you'll be able to do all of the homework. All right. Question?
What if like there's an y and there's an x?
So if you have y times x like that, then you can't do anything. You're just going to sandwich those together. So that's going to equal xy or yx. It's the same thing as yx. Yeah. So with different letters, you just kind of squish them together like you're throwing them in a blender. Just throw them all together. They're good. It's a sloppy Joe sandwich. I don't know. All right. So this was our old rule. It was a rule of exponents. If I have the same base to the n, same base to the m, and I'm multiplying those two, what is this? What is this thing? Try to get someone new, if possible. Does anyone still have a card? You turn in your card, Sergio. Jessica turned in her card already. Monse, is that a hand? No? No? All right, Jessica, go for it.
X to the power of n plus m.
N plus m. That's the same thing that we just said right here. Right here we said you add the exponents. You're adding the exponents. You're adding the exponents. It's the same rule. Thank you, Jessica. Where are you? All right. And here is the extension of that rule, a new little tweak to the rule. If I have a number out front with the same rule, it's the same thing except I have an A and a B. What is this going to be? Does anyone want to take a guess? What is this going to be? Gunnar, go for it. All right, no one wants to go for it. It is kind of hard. Cohen, go for it.
AB x.
There it is. Yeah, good job, Cohen. AB times x to the n plus m. That was a hard one. I just multiply the numbers out front, and then I add the powers. These A and B, those were the coefficients. I multiply the coefficients because I'm still talking about multiplication here. So I still multiply the coefficients, and when I'm talking about the powers now, I still have to use this rule of powers where I add the powers. All right, this rule that I just started can be written in words. If you don't like the algebra, I can say it in words. When multiplying the polynomials, so here's a polynomial, here's another polynomial. When I multiply those two things together, I do what to the coefficients and I do what to the exponents. Who can help me fill these in? What did I do to the coefficients? Well, here are the coefficients, A and B. What did I do to get to AB? Fernando.
Multiply
There it is. I multiplied those two.
and add.
Multiply the coefficients and add the exponents. Perfect. Thank you. Everyone write that down. Fernando's rule. Multiply the coefficients. Add the exponents. Why am I not struggling with the alphabet today, I guess? Multiply the coefficients. Add the exponents. Every single time, over and over, it's the same rule. All right. I'm down here on example 1. Who can multiply the coefficients and add the exponents for me? I'm just applying this rule, which is the same thing as this rule, which is the same thing as this rule. It's the same rule over and over in multiple forms. Jose.
So 6x to
To
the power of 3.
the power of 3. How'd you get 3? What were you adding to get 3?
The 3x has a 1, right?
The invisible 1 plus the 2. Yes. All right, there it is. 6x to the power of 3 is our final answer. Thank you, Jose. All right, let's see if someone wants to take a shot at example number 2. This one is a little bit tricky. There's a word for when I multiply something, one something times two somethings. Does anyone remember this word where we multiply this negative 4k into each of these terms? What is that word that I'm looking for? Ooh, vocab word. Gunner. Distribution, yeah. So I'm going to distribute that negative 4k into both of them. Write down the word distribute. If you forgot, it's distribute. Thank you, Gunner. And your card is now in, Gunner. All right. I need someone to distribute that negative 4k into the 5k cubed and that negative 4k into the 2. Ooh, that 2. That's going to be a little bit tricky. I wonder if anyone's going to be able to do that. I see one hand, two hands. I see Fernando and Jose. Anyone else want to take a shot at it? I'll alternate back and forth. Let's give it to Fernando.
Okay, so negative 20k to the power of 4.
I'm going to pause right there. Negative 20k to the power of 4. How did you get to the power, or how did you get that negative 20? Just re-explain it to us.
Multiply the negative 4 and 5.
Okay, negative 4 and 5 is indeed 20. And then how did you get the 4?
Plus 3 and the invisible 1.
And the invisible 1, yeah, perfect. So this is 4k to the power of 1, and I do get to the power of 4. Okay, continue on, Fernando.
Minus 8 to k to the power 1.
Power 1, yep, there it is. Box it, final answer. Thank you, Fernando. I just want to point out that whenever I multiply a number by something that has a letter in it, so these two terms, I have a constant term and then a linear term. These are using those vocab words from 14-1. You just have to multiply the numbers together, just like before, number times number, 2 times negative 4, and then just leave the exponent. You don't have to do anything with that exponent. It was k to the 1, leave it k to the 1. All right, give me a fist of 5 on examples 1 through 2. Examples 1 through 2, how are we following? I see 4, 5, 5, 5, 5, 4, 1. No, that was a 5. Okay, cool. Mostly 4s and 5s. All right, our final example. I'm going to use that same word, distribute. Who can do that entire problem for me? Entire problem for number 3. See Jose's hand, Fernando's hand again. Anyone new want to try it? See Cohen's hand. See Sergio's hand. All right, Sergio, give it a shot.
So it's negative AB to the second power to times 4. So it's negative 32.
Yep, negative 32.
B
V
to the 4th
to the 4th. All right.
plus 48B to the 3rd power.
V to the 3rd. You have it correct. And that's because we had that invisible 1 here. 1 plus 2 is indeed 3. And box it. Thank you, Sergio. All right. I'll let you keep copying that down. And then my final question before we do the summary. Fist of 5. How well did you follow today's lesson? Fist of 5. See, 5, 5, 4, 4, 5, 5. All right, 4s and 5s. That's doing pretty good. Go ahead and write a quick summary, and then you have the paper homework assignment in front of you. It is 10 problems long, doing problems similar to example 2 and example 3.